Thank you for joining us for today's session. Today we're talking about running containerized Linux apps with Azure, and I will hand it over to our instructor, Sydney Andrews.
Hey, Matt, thanks again for introducing the session. Welcome, everybody. We've been having some great sessions as part of this series on deploying applications to Azure App Service. And today, what I really want to do is just really go into how I would work as someone who wants to Dockerize some of my applications and push them to Azure App Service. So again, really excited to show you a lot of technical demos today. In the past, Matt and I have actually talked about this with people, and we delivered webinars before, and we found that people have different varying experience levels with Docker. And so one of the things we do is that we just try to explain everything as we go. So there may be a couple times where I say, hey, here's what Docker Run does, and you might go, oh man, I've worked with Docker for so many years. You don't have to tell me what Docker Run does. And I promise we're going to get into some really fun demos. It's just we always like to make sure that we cover all of our bases and everybody has an equal opportunity to learn how to do this. So I got quite a few goals today. I'm going to just walk you through some sample containers of Docker Hub. We'll pull them down locally, just run through the basic Docker commands I'm going to be using today. Then we'll use the Visual Studio Code extension for Docker to manage our containers that we built locally and see what's running, what's stopped, and do just a little bit of admin on Docker. And then we will build some web containers. So we'll build a really simple one where we copy an index.html file into an Nginx container and then just push that to Docker Hub and then publish it to Azure App Service. We will take a step further. We have a Node sample application we used in our first session. It was just a very basic Node.js Express app that I think it served just an index.html file and a ping image. We'll take that, we'll put that in a Docker container image, publish it to Docker Hub and push it out. I'm going through my notes here because I love to run through a lot of demos. We will then take our Next.js web application that we use in past sessions, do the same thing there, show how it's very similar because it's built on top of Node.js, and we will push that to Docker Hub, test it out on Azure App Service. Then I'll walk you through how you can use Docker Compose. And again, everybody has different levels of experience with Docker Compose. So I'm going to try and teach this at the 100 level rather than try to go deep in and assume everybody's done Docker Compose before, because you'd be shocked how many people have worked with Docker who've never worked with Compose. So we'll take the sample WordPress Compose file that the Azure App Service team likes for you to start with when you're building your first multi-container app on App Service. And then we will try to take our Next.js app, and depending on how much time we have, I might skip a few steps, but we'll take that and we will build a MySQL database, seed it with data, and build a multi-container app with our Next.js front end and our MySQL database and publish that to Azure App Service. So a lot of goals today, really excited. We have our Q&A, so if you got questions, please post them in the Q&A. I try to answer as I go, but I'm human, I'm not perfect. I may miss your question. I may try to answer your question and get it wrong. If I do that, msusdev@microsoft.com. That's our email alias, and we're starting to get some questions in. I have two questions, Matt's going to pick on me after the session, that I have to come up with some concrete answers for. I'm researching, because people are sending us really good questions. That's what we like. And again, if we can't answer them, we'll find you somebody who can. So msusdev@microsoft.com if you don't feel like you were given an answer in our Q&A today. So without further ado, let's just jump right in. So I'm going to open up my browser, and here I have the Azure portal open. We're going to come back to that later. I'm going to go to Docker Hub. That's hub.docker.com. I'm going to copy that URL, post it here in the middle of the screen, and then make an announcement in the Q&A. So if you haven't went to the Q&A yet, please go. Matt, myself, Alexi, we've all made announcements there with links to past sessions, MSUSDev if you have questions, our code of conduct, registration page for our final session, and then where we're going to post today's session once the recording is live. So lots of stuff in the Q&A if you haven't been over there yet. So hub.docker.com, I posted that URL in our Q&A. And what we're going to do is we're going to just jump in and just look at some sample containers. The one that I think of the most when I think of web development is Nginx. So I'm going to search for that, Nginx, and we'll see there's an official container image with 10 million plus downloads. And if we wanted to use it, we'd have to just use Docker pull nginx to pull this down. And we can see this for other container images. Like if we're building a node application, we probably want to start from that node base image, which is very similar. A lot of downloads. It's official. And you just Docker pull node to pull that down. MySQL, if we want to use the MySQL database. Again, an official image with many downloads. Docker pull MySQL. You start to notice a pattern here. If we wanted to work with a platform like WordPress, very similar situation here. Official image, 10 million plus downloads, Docker pull WordPress. So Docker Hub really is just think of it like it's a container registry officially. But if you've never worked with a container registry before, think of it like a repository of container images that you can pull past versions and current versions and use with your applications with your containerized applications to build more and more complex solutions. So if we wanted to use Docker, we use our command line. And you're going to see me use the command line a lot today. So I'm going to zoom in really good so you can see everything. We'll start with Docker version. So I can show you the version of Docker on my local machine. And obviously, if you're watching this as a recording, you probably have a much later version. Docker info will give you even more metadata and a different set of metadata so you can see lots of interesting things going on there. And clear my screen. So that was just Docker version, Docker info. If I want to pull a container image, just Docker pull. And it looks like my presenting bar is right here. Wonder if I can make that hide. There we go, Docker pull. I want to pull the node image, so Docker pull node. We can pull other container images. You'll see it's downloading, then it's going to start extracting, and then it's going to be ready for us to use. One of the cool things you can do, once this is downloaded, you can use that container image. So give this a second to finish. Should have pulled a smaller container image from our first one, but demos, this is how they go. All right, so there we go. And we can use it by just running Docker run node. Now, one thing I like to mention to everybody is really important when you build your first Docker files, or you think of Docker and composing container images, composing multiple containers, is that a container really does one task. And that's really important to remember. That task could be as simple as collecting some data and printing it out. It could run some operation. If you're having a web server, that one task could be to start, listen for requests indefinitely, and just wait indefinitely. So that one task, you can be a little tricky here and make that one task something where it runs indefinitely, but all containers run a single task. So this node container doesn't really have a task associated with it. So if I hit Docker run node, it's going to start the container. Nothing's going to happen. It's going to return. Now, if we wanted to, interact with this container, we need some way to stop that container from finishing. So we can connect to it using a sudo tty console. What this does is essentially creates a connection to that container and holds it so it doesn't stop for us. If we want to interact with it, we'll use the interactive command. Now, you've probably seen this before because you've probably seen people say Docker run it, which is shorthand for -i-t, which is shorthand for --interactive --tty. So if I do that and say node, I can even specify what I want to run. So maybe I want to run a bash shell. So I hit enter. And now I'm interactively within this container image, and it's holding that connection so the container image won't stop before I'm done. So I can dir, see different folders, like I can cd into the user folder, dir that. I don't think there's much in here. I can even exit out. And at that point, the container image will stop. And we can do this with other container images. I can pull MySQL. I can pull nginx. I can even pull, I think it was one more, WordPress. Actually, I'm not gonna pull WordPress. We'll save that for later. We can also run different container images in a detached manner. And I see one Q&A question coming. I'm gonna get to that in just a second. So we can attach to it and interact with it, or can run in a detached manner. That's really useful if we have like a web server. So if we want to run a container image and have it listed on a port, we don't really want to connect to that right now, but we do want it to hang out. So let me clear my screen. Docker run, and this time, instead of interactive, I'm going to say detach. And we can run something like the nginx image. Now, This is fine and dandy, but if this is a web server, how do I actually go in and connect to it? And we would need to open a port. So we know Nginx is going to listen to port 80 by default. So we could type in publish to publish a port. There's a couple different ways we can do this. We could just type in port 80, and what Docker will do will take that port 80 and map it to some random port that's available on my system, or we can specify what port. So I can say 1788, map it to port 80 for my container image, which is Nginx. And so on my local host, I'll be able to access this using port 1788. So I'll hit enter just to show you how that looks. I get the unique identifier for my running container, which is still running even though it's returned. I can do Docker run detach. This is how I'll call this, give it a different name. Nginx the second. I'm gonna publish port 80 and just run that Nginx container. Now, how do I actually check on things? I'm gonna show you, and somebody actually clarified, I did make a technical error. The single task the Docker image can do is to start something. Now, I'm trying not to get too much into detail, so let's actually move to the next step, and then what I'll do is I'll show you how we can admin this. So we can run Docker PS to see our running containers, and we'll see here that for Nginx, that first time we ran it, which has been running for about 51 seconds, I mapped port 1788 to port 80. And for the second one, Nginx the second, love that name. The first one got a friendly name generated by Docker, which is friendly buck. But for mine, Nginx the second, it went ahead and mapped it to 56419. That's a really fun port number. Okay, so I'll show you through the command line how we can manage this. But what we're going to do for most of the demos today is we're going to do the same thing, but from Visual Studio Code. So I'm going to just go ahead and close my command line and open up Visual Studio Code. Now, you need to open up Visual Studio Code in the context of a folder. So I'll just open a folder, go to my downloads, and I'll create a new folder. I'm going to call this Docker, just for fun. Once we open up Visual Studio Code in the context of a folder, we can go to our extensions and look for a Docker extension. And if you don't already have this installed, you can install it. It not only allows you to manage your containers, it also gives you really great intelligence on Docker Compose and on your Docker file. Saw a Q&A question. Hey, demo notes for this session. One of the demos blew up on me right before this session started. So I'm modifying the demo notes. I'm gonna have them up within an hour after this session is done. All right, so going in, I'm gonna just jump into Docker right here. And you see I have my two Nginx running, Nginx the second and friendly buck. You see I ran node twice. One was hardcore Minitsky and objective pike. You can see they exited 4 or 5 minutes ago. Both of these running about 2 minutes. You can see all three container images I downloaded, which is Node, Nginx, and MySQL. You can even see different registries I'm connected to. So for instance, if you want to connect to Azure Container Registry or Docker Hub or any other type of registry or GitLab, you can connect to them right from within Visual Studio Code to make it really easy for you to publish your container images. So lots of really cool tools here. And like for example, if I highlight Nginx the second, I'll see that it has a port button here, and I can select this port button. And what I'll do is I'll open my default browser at that port number. I can also just right click it and open a browser. So there we go, Nginx at port 56419. So really cool way for us to get comfortable with container images. And we can do all sorts of interesting things, like we can stop these containers. I'm gonna stop both of them. I can prune from right within here, which is pretty much any container that's not running. I'll remove that container, which is different than a container image. So think of a container image as kind of like the recipe of the source, whereas the container is the actual running instance. All right, somebody asked, detach, interactive, are they different? They're different flags for Docker run. Detach again allows you to run it kind of in the background. Your command prompt doesn't wait for that container to finish running before it returns. So it's a way for you to say, no, wait, essentially. Interactive, along with the TTY flag, allows you to directly interact with the container. And when you're done interacting with it, it will go ahead and close. For today, we're going to be running things in a detached manner since we're essentially building a whole bunch of containers for Azure Web Apps. So that's a great question. The person asked that. There was another question that came up. Somebody says, hey, if we have a running Docker container, can we publish a new port? I actually haven't tried that yet, so please send that question to our msusdev@microsoft.com. We have a couple of questions in the queue, but we'll get to you as quickly as we can. Thank you so much for asking that question. And just again, I'd like to make sure I answer as many questions in the Q&A as we go. So I want to start building stuff that I can publish to Azure App Service. I'm going to just start really simple. I'm going to go to one of the repos we've been using throughout all of our sessions, and this is a repo with a really simple Node.js app that serves an index.html file. And I'm going to go ahead and post this link in the Q&A because I like to share links as I go. And I'm posting it here too, but it's in the Q&A, so I'm not going to hang on it too long. This is our Node.js really simple placeholder JavaScript application. All it does is use Express. It hosts the index.html file and our banner in the public folder using, I believe, the media directory. I'm going to get really lazy today. I'm going to go to my index.html file. There's nothing in here that doesn't make this a static website, so I'm going to just copy it. Then I'm going to go back to Visual Studio Code, and I'm going to create a new file called index.html. And I'm going to just paste this HTML file in here. Again, nothing too crazy yet. Now, I want to build a Docker container image of my own. So what I'll do, this is for those who haven't seen this before, I'll create a Docker file. And again, I'm going to try my best to explain this, but this is not really a Docker training session. I just want to explain enough so everybody can be dangerous when they get into Azure App Service. So a Docker file is really an algorithm to create a container image. It's a much more technical explanation, but when I first learned it, that's how I thought of it. Like, here's a list of steps to follow to build my container image. So we start from somewhere, we complete a couple steps, and then we end up with a container image. So for example, I want to start from the Nginx container image. We've tested it, we know it works. And I'm going to copy my index.html file. Now, where am I going to copy it to? See, I need a source and a destination. So these are my first two instructions. We're going to start from an Nginx container image, and our first instruction is to copy a file. This index.html file is our source, and I need to put it somewhere. So how do I find out? Well, I'm going to go Docker run interactive TTY Nginx, and I believe I can specify bash here. I think so. We'll see. There we go. All right, there. So where do I want to put this content? So I did a little research. There's a folder here called share. There's a folder in there called Nginx. I just typed Nginx. I need to type Nginx. And then within here, if I dare, there's a folder called HTML. So it's user, share, Nginx, HTML. I'm gonna go ahead and exit. And now I've used a little bit of, I used a little bit of sleuthing to figure out where I want to put this content. So I'm gonna put it in user, share, Nginx, HTML. So here's what I'm doing. I'm keep it super simple right now. We're gonna start for the Nginx container image. We're gonna copy this index.html file into that special folder, user share Nginx HTML. Somebody asked, hey, if I want to learn Docker from the ground up, is there a training content out there for that? There is multiple Microsoft Learn modules that'll just teach you Docker from the ground up. I even have, I know this is gonna sound really crazy. I even once upon a time, tongue twister, built a Katacoda module on learning Docker if you've never worked with Docker before. So there's a ton of content out there. I'm going to make sure I update our landing page with training content on Docker. And I apologize for not having links there already. I didn't think that would come up, but I'm glad you brought it up. So thank you so much for bringing that. We'll make sure to add a couple links on actual Docker training for people who've never worked with Docker before. So now that I have a Docker file that tells Docker how to build my container image, I need to tell Docker to build my container image. So I'm going to do Docker build, and that's the command we're going to use to build our container image. We need to tag our image. So I use the tag, and sometimes when you see documentation, you see .ht, but I always like to use the full command so everybody can learn. Docker build tag, and I'm going to call this vanilla site. Now, once I've specified a tag, I need to tell Docker build what I'm building. The Docker build is going to look for a Docker file. Since, let's see, what folder am I in? I'm in the Docker folder. So actually, let me back up. I'm in my downloads folder. I'm going to dir. There's a folder in here called Docker. I'm going to cd to the Docker folder. Apologize for being in the wrong folder. We'll do it again. Docker run tag. We're going to call it a Sydney vanilla site. Sydney vanilla. And then we need to tell Docker run what to build. I have a Docker file in this folder. So I hit dot, hit enter. Building, not Docker run. I apologize. See, when you switch folders, you get confused. Docker build, and there we go. It pulled the Nginx really fast. It copied my index.html file really fast. And the reason it did that so fast is because I've already pulled Nginx before. Somebody said, hey, I'm in Visual Studio Code. Can I build? Yes, you can actually specify to build directly from here. So you'll see there's our container image we ran earlier. And there's my Sydney vanilla image that we built. There we go, Sydney vanilla, and it automatically applies the latest tag after that. So I want to run it? Sure. I can either Docker run, just like we did the detach, or I can select right here and select run from here. Just for fun, I'm going to Docker run detach, publish port 80, and I don't care what port we publish it to, and we're going to run Sydney vanilla container image. So see here, Sydney vanilla is running, and it's published to port 60339. I didn't specify a port to publish to, so I picked a random port for me. This is great when you're doing a lot of dev. And there's our placeholder site from Katoso Spaces. Now, I want to put this on Azure. So how do I do that? Well, I'm going to go back to Visual Studio Code, and you notice I'm connected to two different registries using two different accounts. One is my personal account, and then I have our demo account that we use for sessions like today with plenty of container images there. So we have Sydney vanilla. I'm going to select this latest container image, and I'm going to select push. It's going to say where you want to push. I'm going to push to Docker Hub using my demo account, MSFT US Dev. What namespace do I want to use? Same namespace. What do I want this image to be tagged as? I think this is acceptable. MSFT US Dev Sydney vanilla latest. I'll hit enter. It's logging in. It's going to open a terminal where it's executing Docker push. And it's pushing to my Docker Hub. Somebody said, hey, use cases that I would look for Docker containers over just deploying my code natively to Azure service. I'm a big believer in not tying yourself down to any particular service or any particular provider. One of the things that's really important, especially in big enterprises, is building your code in such a way that if your organization needs to make a monumental change, wherever you change cloud providers, or you even just change something as simple as we're moving from one Azure service to another, if your code is not portable, then you run into all sorts of issues and all sorts of rework. And I like Docker because with Docker, not only can we dev using Docker containers locally, we can push those same containers to production. We can push those same containers to different environments and expect reproducible behavior. So it is very much like containers on ships. We have a very strict packaging format it comes into, and it keeps things portable so that if we go from, I always like to use that metaphor of shipping cargo ships. If we go from the ship to the trucks that drive the cargo containers around to wherever the target ends up, we all know and expect a certain package and container format. So the great thing about this is that if you use Docker, you're pretty much portable. You can use Docker across a wide variety of Azure services, not just app services. There's Azure container instances. If your organization, this happens so much more often than you realize. Now I realized for a long time. One day you're building container images, you deploy an Azure App Service. The next day somebody comes to your shop and says, we're going to Kubernetes. Well, we don't really have to change that much about our developer workflow because we're already Dockerized. So the idea here is that we have a wide variety of services that we can go to because we're using a common package format. All right, so I answered that question to buy myself some time. We're going to go to hub.docker.com, and I'm already logged in as this user. So I should see my Sydney Vanilla container image. And there we go. MSFT US Dev Sydney Vanilla is the name of the container image. I'm going to copy that. And then I can use that in a deployment. So let's have some fun. So we're going to create a resource. And I'm going to go to Web Apps. I'm going to use my resource group and subscription that we've been using for demos throughout this entire webinar series. And I'm going to say Sydney Vanilla website will be the name of my website. And instead of publishing code directly, we're going to publish a Docker container. So I'm going to set ECS for the region, and I'm going to create an app service plan for this. Just going to call this a Docker plan. The name of the app service plan just has to be unique within your resource group. It doesn't really matter in the grand scheme of things other than to your organization. So we can create different container images here. So for example, we can say a single container. Where do we want to pull from? Do we want to pull from a private registry? If we pull from private registry, it has to support the Docker container registry. I believe it's the V2. The fun thing is actually in Visual Studio Code, it tells you. I just want to make sure I give you all the right information. Yep, Docker V2 API. Any type of container registry support that. Whether you have your own container registry in your enterprise or not. Whoever you use Docker Hub, or if you use a service, Azure service such as Azure Container Registry, which I really like. So from here, Docker Hub, we'll pull our container image, hit review create. And there we go. It's going in our MSUS Dev resource group. We're going to create a web app called Sydney Vanilla website with an app service plan called Docker plan, and we're going to deploy this container image. So I hit create, and our deployment has started. So I'm just waiting for this app service plan to finish being created. And you notice that there's one step I skipped right there, and that was, hey, there are some quick starts. So if you wanted to use a quick start instead of deploying a container image yourself, you can definitely do that. So for example, I can go to create a resource, web app, MSUS Dev, Sydney quick start website, Docker container. I select ECUS, it'll automatically, let's see, hold on, let me refresh. My app service plan must not have been ready just yet. Sometimes you create a little bit of fun race condition there. There we go, there's my Docker plan. Sydney quick start website. There we go. Hit next, go to Docker, and then I can use a quick start, such as Nginx. Notice one thing, when you select a quick start at the bottom, it actually tells you what container image it's going to use. And this is from mcr.microsoft.com. That's the Microsoft Container Registry. It's a really, really cool container registry that is, the term is escaping me. It echoes. No, echo is not the right word. It sends this container registry out to other registries, broadcast them, so that other registries such as Docker Hub, I believe, there's a couple of container registries, third-party container registries, that is also sent out to you. You can go to mcr.microsoft.com. It'll take you to the Microsoft Container Registry, where it tells you about MCR endpoints, how they work, and how they send things out. So it's pretty cool. All right, from here, we're going to go in, hit create. And if you've ever done any, I believe, .NET Core or .NET 5 development, you've probably seen those mcr.microsoft.com container images before, because that's how they deploy those. I believe for the Windows containers, those deploy that way. SQL containers, I've done a lot of really cool demos with SQL containers. Those come from the MCR registry too. All right, so let's start playing around stuff. So we have our MSUS Dev Resource Group. There's my Sydney Vanilla website. Hit Browse. There's our Contoso Spaces webpage. Nothing too fancy yet. Look like a couple problems. My background image is not showing up, so that's not good. I can go in. I think I had another one I created was the Quick Start website, right? So, yep, Quick Start website. That takes us to App Service Developers page. So nothing too crazy here, but I want to fix this. So I want to actually take this web app and publish a newer version of my container image. So I'm going to go back to Visual Studio Code, and I'm going to close out some of these things. I have a lot of stuff going on here, so we'll simplify things. See, right now we have our vanilla website. It's still running locally. I'll stop that and prune my containers. Just keep things simple so you can follow along. What I like to do is improve this Docker file. So there's lots of different ways I can do this. So for example, I know that this index.html file references a banner.ping file in a media folder. So I could just add my banner.ping file. How do I do that? Well, I'll go back to that repo. Where was the repo? Here we go. There's an index.html file. In a public folder is my banner ping file. I'm going to go ahead and download this. Let's see, and banner.ping in my Docker folder. So all I did was just download that banner ping file to my Docker folder, nothing crazy. See, it's partially transparent. I can go into my Docker file and really have some fun. So I can run make dir or make directory, user, share, nginx, HTML, media to create a media folder. And I'm gonna copy a banner.ping file from my local folder to user share nginx HTML/media. That should give us our media file. So if I just test that out locally, so Docker build tag Sydney vanilla upgrade should run pretty fast. So Docker run detach publish port 80 Sydney vanilla upgrade, hit enter. I should go back to this Docker extension, see there's a new Sydney vanilla upgrade container running, 60727, and it has my banner ping file. Awesome. Now, there's lots of different ways we can write this Docker file. So right now, I'm just being explicit as possible. We could use a working directory. So we can say, I'll copy this file. Let's see. Working directory, copy index.html to the current directory, run make directory, create a media directory, and then copy banner.ping to the media directory. I can even rearrange the commands. So I can change my working directory to user share nginx HTML, run make directory to create my media directory, copy my index.html file to the working directory, and copy banner.ping to media directory. Hopefully I didn't make any typos here. So let's build that. And I'm going to use the same tag to replace that. So let's see. Let me stop this. And I'm using Visual Studio Code because a couple people will ask in the Q&A, hey, can you show how to use Visual Studio Code to do a lot of these commands instead of all in the command line? So I'm using Visual Studio Code on purpose. All right, let's see. Docker build and Docker run. Same commands as before, nothing's changed. So if I refresh this, there's that Sydney vanilla upgrade. This time port 55249. Everything works the same, and I can keep going if I want it. I can simplify it even more, but at this point, I think I'm good. If I wanted to, just to show you that there's a lot of flexibility here, I can create a media folder and I can do something like this. And then I can run a copy command where I just copy everything from the local folder into user share nginx HTML. Lots of stuff we can do here. It'll come up really important later, but for now, I think Sydney Vanilla Upgrade is pretty good. So we'll just stick that. So we have two container images. We have latest, which is that one we built earlier, and then upgrade, which is what we just built. I'm going to push upgrade to Docker Hub to my MSFT US dev, and I'm going to leave the tag upgrade. But I could change this right here to maybe something like V2 if I want it. Hit enter. And you notice that I'm using a completely different name for that container and tag on Docker Hub that I'm using locally. So here we go. I'll go back to Docker Hub, or if I can find it. Here we go. Let's see. Here's Sydney Vanilla website. Hub.docker.com. Sydney Vanilla. I have two tags, the latest to V2. V2 was just published a few seconds ago. Awesome. And go back to Azure App Service, and I'm going to go to Deployment Center. Deployment Center is where we can configure deployments. If you've been to any of our previous sessions, you know we've used this quite a bit before. So use Deployment Center even if you're doing container-based deployments, whether you want to do manual deployments or where you want to set up continuous deployment. So we have a single container from, this is the quick start. I apologize. So the quick start has a single container for mcr.microsoft.com, which is a private registry that serves app service static site latest. Let me show you another example. If we go to Sydney Vanilla website and hit Deployment Center, we'll notice this one serves from Docker Hub with a public container image. You can always use private if you want. MSFT US Dev Sydney Vanilla latest. I'm going to change this to V2 and hit Save. All right. And I'll just show you something really cool that's happening here. If we go to logs, we can actually see the logs used to pull our container images. So when we pull Sydney Vanilla, just like we had locally, we have our container log showing when it's pulling and extracting, all that fun stuff. Let me refresh it. There's when it pulls Sydney Vanilla. Now it's pulling Sydney Vanilla V2. There we go. It looks like it's ready to serve requests. So if I hit browse, we're now running Sydney Vanilla V2. And you can actually set up, again, continuous deployment. And what it'll do is it will connect to, connect to Docker Hub and trigger off certain events that you configure. So we can definitely do this with a simple vanilla container, but you didn't come here to see me deploy vanilla containers. You came to see me deploy a little bit more than that. So let's have fun with this. So I'll stop this container instance locally, remove my stop container. And before I move on to the next step, I want to show you one cool thing. If you remember, we used the Azure extension in previous sessions. It's going to open up Visual Studio, another instance of Visual Studio Code. And in this one, I'm going to, wrong folder. No worries. In this one, there's nothing secret in there. I'm going to open up the Azure extension, zoom in a little bit so you can see. And we have App Service running here. And let that load up so you can see. And we're looking for a Sydney Vanilla website. Oh, you know what? I opened in a really busy folder, so I should have checked on that first. All right, there we go. Concierge description. There's Sydney Vanilla website. Just so you see that. You can see I have deployments. You see different things like my Docker registry server URL and application settings. So it's really cool. You can even go and select and browse website and browse the website. So we can still manage it using Visual Studio Code if you want. We don't have to use the portal. And I'm just showing you lots of different ways to manage the same thing. All right, so let's move on. We're going to do our node site and then our next site. Next, a pun not intended. So we'll start off with our node site. So I'm gonna just open this in my file explorer and there's my Docker folder. I'm gonna just delete everything in there. And then from there, I'm going to go ahead and clone an existing repo. For those who follow along, I'm going to clone that repo that we looked at before. That's that deploy web app slots repo that we used from previous sessions. So just run the terminal, clear, git clone, deploy web app slots, and create a mslearn deploy web app slots folder. Now, if I wanted to clone that into my current folder, and I'm doing this on purpose just so you see, I need to provide admin permissions. Hang tight. I'll just go ahead and delete that. If I run the same command, but hit a dot after it, I'll just say clone into the current directory. And I'll open code insiders and dot in the current directory. There we go. So there's our application. Same application, same index.html file, but this time we're using nodes. So our Docker file is going to have to be a little bit more complex. So we'll create a Docker file. And since I'm building a node project, let's test it first. So I'm going to open up Windows Terminal, clear my screen. Npm install to install my Npm packages. And then after Npm install is done, you see this one, Npm install takes a second. Npm run start, that should run a development server at port 8080. So if I control click this from Windows Terminal, it'll take me to port 8080. Awesome. Go back to Visual Studio Code. Visual Studio Code might have prompted me for an update. That would be terrifying. We're going to say from, but instead Nginx, we're going to start from the node image. I'm going to run a different tag. So not just node. You see there's all different options here. I'm going to use the one based on Alpine Linux. I'm going to create a working directory just like we looked at before. I'm going to use my app directory. I'm going to copy all the files from our local folder into this app directory. And yes, I know this will copy the node modules. You can set up a config file to filter it so it doesn't copy node modules over. This is just a simple demo, so I'm not going to worry about that, but it's just something to know. I'm going to run Npm install to install my everything I need in here. I'm going to expose port 8080. Since this is just running at port 8080, I could also choose, if I don't want to expose port 8080, I could also use the environment command to set the environment variable port 80 and expose port 80. But it's a fun demo. I'm just going to expose port 8080 for simplicity's sake. And then I'm going to have a command that executes. So this command is going to be npm run start. Hit save, and I now have a much more complex Docker file. I'm going to go in, application for running, clear my screen so you can see everything. And from here, I'm going to build Docker build tag Sydney node current folder. So let Docker build work his magic, pull the node container image, is running npm install, and there we go. So from there, if we go back to the Docker extension, we'll see we have a new container image called Sydney node. We're going to take that container image, since we didn't specify a tag, has the latest tag. I'm going to right click that, push to Docker Hub, msft usdev, Sydney node latest, hit enter, and we're pushing that to Docker Hub. And I know this question is going to come up in the Q&A, but you can definitely set this up with GitHub Actions, Azure pipelines for continuous deployment, continuous integration. Matt and I may have to go a little bit deeper into that, because we actually did touch on that quite a bit in both our GitHub Actions and Azure DevOps sessions, where we showed you how to automate the publishing and build of a Docker container image. But definitely seems to be a lot of interest for that here. Somebody asks, hey, so you have two commands that actually run something. One's called run and one's called CMD. What's the difference? Well, with run, we're just executing a command as a step to building our container image. With CMD, it's a default for the executing container. So what should this container do by default if you specify nothing? So if you Docker run Sydney node, what should it do? Here I say run npm run start. But CMD can be overridden. You can definitely specify something else to run instead of that. All right, so I pushed everything out. So if I go to Docker Hub, I'll just go back to there. Let's refresh my homepage. There's Sydney node. I'm going to go back to the Azure portal and create a brand new web app. MSUSDev, Sydney node website. Docker container, ECUS. That way, I can use the same app service plan. I go to the Docker step. This time I'm going to choose Docker Hub. msft usdev Sydney node. Let me make sure I type that correctly. I'm known for mistyping things. Copy that, paste it, hit review and create, hit create, and it's deploying. I mean, we could take it a step further. Like if we wanted to build another type of site, we could do that too. So here we have our Node.js website, but remember I showed quite a few times we have a Next.js version of this website, and that's actually, let me pull this up, github.com/Microsoft Docs multi-container web app. Paste this link in the Q&A. And this is our Next.js application we used in previous sessions. I'll copy the URI. I'm in the Docker folder, so I'll cd out to my downloads folder, git clone this, and I'll just say Next.js is the name of the folder I want to clone into. So I'll clone from git, cd Next.js, clear my screen, code, insiders, dot. And I'm running insiders build a code just to, because I always like to use the latest and greatest. From here, I can see that this is our Next.js application. You build it by running next build and start it by next start port 80. Awesome. Somebody said, hey, I'm hiding sensitive information on my browser. This is a tool? Absolutely. There's tons of tools to hide your Azure sensitive information in the browser. All right. Jumping back in, I have a couple of branches for this project. One is called Docker single file. And in here, we have a Docker file. Starts from node alpine, changes our working directory, copies everything to the app directory. It runs Npm Install and Npm Run Build. Exposes port 80 since with Next.js, I don't have to worry about port 8080. And then from here, cmd Npm Run Start. So I go in, I can build this container image. So let's see. Docker build tag Sydney next current folder. It's building my container image. And while that's building, make sure I didn't blow up any of the previous demos. Looks like my Node app is finished deploying. Go to my Node website, hit browse, and there it goes. It's funny because Azure App Service will detect that port 8080 is the one exposed, and will automatically map that to port 80 for us, which is awesome. Always love that. We'll go back to Visual Studio Code and my terminal. Looks like it's almost done building my container image. We're at about 30 seconds now, so not too long. This next one is definitely a much more complex build. Now it's running Npm Run Build, which will run the next build process. Just give it a second to do this. If you remember when we deployed the static web apps, we ran next export instead of next build. Difference is next build builds application requires node, and it's still a dynamic application. Next export creates a static website with all potential routes. Somebody says, hey, you set copy, and do you have to specify app? Is it necessary if you already set the working directory? This is actually in this, now you hit the limits of my Docker knowledge. I've never understood why I've had to do that. And it's probably because I've been running Windows, I'm using the wrong syntax for the copy expression. But somebody much smarter than I probably looking at this and say, oh no, you don't have to specify app again because you've already changed your working directory. But I've always done that, and I don't know why I do that. And I apologize if there's a better way. Somebody's probably in the comments right now ready to jump and say, yeah, there's a much better way of doing that. All right, so we're going to go back to our Docker extension. We now have Sydney next. We are going to publish that just like we did everything else at MSFT US Dev. We're going to publish Sydney next. It's going to open up a terminal. It's going to push this to Docker Hub. We're going to, hopefully this goes pretty fast. Oh, 127 megs. That's not little. That's okay. And it's still working. And then once it's done pushing, we'll be able to just switch over to our browser window, go to Docker Hub, refresh this homepage, and there's our Sydney Next container. And we'll create one more web app. Sydney Next website. Select Docker container. I'm being repetitive on purpose. ECUS, we'll go to Docker. We will select Docker Hub. Image and tag is Sydney Next. Review create. Hit create. And once this is done, we'll have our Next.js website deployed to Azure App Service. So had a lot of fun. Deployed definitely a lot of stuff. But what I like to do is take this a step further and deploy applications that require 2 or more containers using Docker Compose. So I'm going to go to docs.com and I'm going to go to Azure. I'm going to select App Service. There's tons of stuff in here, but I'm going to go to Tutorials. Under Custom Containers, you'll see Multi-Container App. And I'll just pop this link into the Q&A for anybody who needs it. And from here, we see that you can actually deploy multiple containers using a Docker Compose file. So they even give you a sample. So just for simplicity's sake, I'm going to close this folder in Visual Studio Code Insiders, open up my terminal, cd out of Next.js. I'm going to create a new directory called deploy or compose. I'll call it compose for fun. cd compose, clear my screen, code insiders in the context of the compose folder. Why did it open another window? I'm no luck today. All right. So we have code insiders in the context of the compose folder. And from here, what we're going to do is somebody already answered. So we don't have to specify app again. We can just specify /, and that will copy just fine. Thank you so much for everybody in the Q&A for participating in fixing my typo. All right. So from here, I can build out a Docker Compose file. So I'll do docker compose.yaml, and I'll paste in, well, not the URL, but I'll go back to the browser and copy this sample from the Azure App Service team, paste that in. Let me walk you through this sample. So this is a Docker Compose files version 3.3. It's going to create 2 services. One is called database, one's called WordPress. I'm going to format this because I really don't like this formatting. Oh. I had a formatter installed. I apologize. I don't have a formatter for Docker Compose. I have to fix that later. All right. So from here, we have our DB service, and we are putting in an image for MySQL 5.7. We have a volume that's defined down here called DB data. We're going to mount this in the var lib MySQL folder. If it fails, we'll go ahead and restart. So that's what restart always means. We'll set 4 environment variables. Some WordPress for the root password. For the database, it's going to be called WordPress. The username and password will both be WordPress. Then we have a WordPress application. It's going to depend on this DB one. It's going to pull the WordPress container image from Docker Hub using the latest tag. It's going to map port 80 internally to port 8000 externally. If it fails, it's going to restart. And you notice for DB user and password, it says the same thing as WordPress. And then for the DB host, it says DB:3306. Now, one thing I want to call out here. How do we know that the host name is going to be DB? Why isn't it localhost? Why isn't it an IP address? Why is it DB? It's because up here we defined the service as DB. That's our host name. So down here, the host name is going to match the name of that service. So if we change this to fun, our new host name has to be fun. Just set it back to DB for simplicity's sake. I'm going to save this file. I'm going to go to the Azure portal. It looks like our next app is already ready. We can go in, check it. Nothing fancy or exciting here. So we'll go ahead and close that. And from here, what I'm going to do is I'm going to create a new web app. I know I've done this like 6 or 7 times already, but I promise this one is going to be a little bit different. As a question in Q&A, I promise I'll get to it in a second. All right, Sydney WordPress site. ECUS, so I have my Docker plan. And this time, instead of a single container, we're going to select Docker Compose. Where we're going to source our images from, Docker Hub. We're going to use public images. And for the configuration file, we will go to our Compose folder and select Docker Compose.yaml. And you'll see there's our configuration file. We'll hit review and create. And we're going to create this web app. So we'll wait. It's going to begin the deployment. And once this web app is deployed, it's going to create a multi-container web application with both containers running within this web app instance. All right, there's a question somebody asked. What's the difference between a Docker file and a Docker Compose YAML file? Well, a Docker file defines how to create a single container image. A Docker Compose YAML file talks about how to take multiple containers, configure them so they can work together in a single application. So that means somewhere there's a WordPress Docker file and a MySQL Docker file defining those individual containers. And then we're using those container images, and we're using those container images in our Docker Compose file to create a multi-container solution. Thank you for asking that question. That's one of the things I should have brought up earlier, but you always get somebody ask the question, you're like, oh yeah, I should have said that. All right, so this takes a second to spin up, so we'll just leave that as this WordPress, so there's some initial configuration and all sorts of jazz going on there. But basically, what we created is app service app that's running multiple containers at the same time. You can see there's our Docker Compose file. You can see if we go to logs, see if the logs are ready to show up yet. This is sometimes when I'm playing with cutting edge demos, I'm a little worried that I'm clicking buttons too fast and I'm not explaining things enough. So we'll go in and we'll see. Come on, logs. There we go. So it's pulling all of our different container images. So if I go up, it's pulling WordPress. Earlier it pulled MySQL. Slow down, there's library MySQL. If I scroll down, it pulled MySQL successfully. Now it's pulling library WordPress. And it's still pulling WordPress. Somebody said, hey, you mentioned in that Docker Compose file, there's a setting called volume. And I skipped over that a little bit on purpose because I didn't want to go too deep into it. But basically, you can use containers in an entirely disconnected way where there's technically storage. Yeah, absolutely. Storage running with the container, but nothing that you can access, you can manage. But you can also mount volumes. So think of them, and I'm being very 100 level here on purpose. I'm not going to go super deep into the technical explanation, but think of them as almost like shares you can mount on a individual container image if you want to actually be able to access that data or manipulate that data in some way. We're going to take advantage of volumes a little bit later because we're going to mount some local files into a volume on a container image so that we can run an initialization script for MySQL. So we'll hang tight. That's a great question. Thank you so much for the person who asked that question. So let me refresh. So we got any updates? Start our multi-container app. WordPress site is ready to go. Let's see. Let me refresh this. There we go. I'm now being asked to install WordPress. Like I said, site title, username, password. I'm going to take this down so I'm not too worried about people seeing that. So we deployed a multi-container app, but I mean, the WordPress sample is just that, it's a WordPress sample. The last thing I want to do today is try to build our own multi-container app. So this is definitely going to be very interactive, very hands-on. I'm winging it a little bit here, but I just want you to see what this really looks like if I'm building a multi-container app using Docker and Docker Compose. So our Docker file and a Docker Compose file. So I have my Docker Compose and YAML file. I'm going to just keep this here. I want to build a multi-container app that allows me to, excuse me, take the data that's hard-coded into my Next.js app and move it to MySQL. So here's what I mean. I have my browser open. I'm going to go to github.com and I'm going to go to my multi-container web app. And I'm going to copy this. I'm going to open up Visual Studio Code Insiders, open up Windows Terminal, CD out of my Compose folder. I'm going to git clone multi-container web app into a folder called Fun Deploy. I'm going to open up a second Code Insiders window in that Fun Deploy window. All right. Clear this out. I CD back into my Compose folder. All right, good times. Now, in this Fun Deploy folder, I have my Next.js app. And the cool thing about my Next.js app is that if I go to the pages, I see that for my index page, it actually loads data from a data.json file. That's how it gets its locations array. And this is where the location data for our Next.js app is shown. And when we say location data, here's what I mean. I'm going to go to my next website, browse this. You'll see that we have different locations you can explore. You can learn more about each location, or you can go to a list of all locations. Now, all this data is loaded from that data.json file, which is incredible for a demo, right? But for a real application, I'd rather this data be in a MySQL database. So what I've done is I've actually gone through the work of converting all of this from JSON into SQL scripts that we can upload this data into a SQL database. So I'm going to just grab this and I'll just walk you through that real quick. So I'm a Docker Compose YAML file. I'm going to just leave that right there and not touch it. I'm going to create a init folder. I'm going to create 3 files. 00, create tables.sql. And in here, I'm going to create 2 tables. And if you're saying, hey, I'm pasting all this really fast, I promise you, I'm going to show you where this is at the end so you can pull this yourself. So this is my create tables.sql file. I'm going to have 01. Since it runs the init scripts in alphabetical order, I put numbers in front so I can control. Insert locations.sql. And this one, I'm going to just copy and paste all 48 of my locations in. It's just a SQL command, enters locations into that locations table. And again, it's not really important what the SQL commands are doing. I'm just letting you know what it is. Insert rooms.sql, and I'm going to grab this. Apologize, I have to do a little bit of scrolling because I clicked the wrong button. There we go. Grab my rooms. And this just inserts data into the location rooms table. So every location has a subset of rooms. All right, so I want to take that data and seed my MySQL database. So how do I do that? Well, I can first just simplify everything I'm doing by just going in and just deleting stuff. Let's just go all the way back to the beginning. We want a Docker Compose file. I know it's using version 3.3. We're just say 3. You know what? Latest version of 3. MySQL, let's use the latest. I could say MySQL 8. I'm going to just leave it to latest. I'm going to leave some of this stuff the same, but you know what? My password for the user and the root should be spaces. My database name should be Contosa DB, and my user should be Contosa. All right, save. Trying to think, is there anything else I should think about? Let's build this. So Docker Compose up. We'll take this Docker Compose file and create a multi-container application and run it. So there we go. DB1 is the name of this. Give it a second to start. All right, it's running. So if I go to my Docker extension, I'll see that I have a Docker container running called Compose DB1. It's running 2 different ports. 3306 is the default port for MySQL. That's the one I care about. It has a volume, even though I didn't specify an additional volume. And then what I'm going to do is just for fun, I think, yeah, I'm going to init some data. So I'm going to define a volume. But instead of defining a volume like we did before, where we put a volume in a list of volumes, I'm going to say take, let me open up Docker Compose and Control C to stop that container. My screen. Let's say take my local init folder and then put that content in Docker entry point init db.d. I'll save that, and this time when I say Docker Compose up, and I promise you I'll show you where all this is. It's going to start my database again. It's fussing at me. Root was created with an empty password. It's a demo. I'm not too worried about that. There we go. We're ready for connections. Create our database, create our user. Maybe make sure I don't have a typo. So I'm looking for where it says note entry point. This actually run my init script. Doesn't look like it's ran, so let me just make sure I don't have a typo here. I'm gonna just copy it from one of my notes. Oh, I forgot a slash. No worries. So I'll stop my Docker Compose and run it again. I'm just running this locally, make it possible for me to test this compose file. So there we go, starting up MySQL. So I'm looking for things that start with note entry point. Database files initialized, starting temporary server. Let's see, temporary server started. Awesome. Creating database Contoso DB, creating user Contoso, giving user Contoso access to schema Contoso DB. Ah, there we go. Run 00 create table SQL, run 01 insert location SQL, run 02 insert room SQL. Stopping and restarting the server, and we're good to go. So now I should have a database that has my seed data in it. And yeah, I could probably play around with it, expose ports and stuff like that if I want to test it out. But one of the really fun ways to test things out is using other container images. So we're going to go to Docker Hub. Let's try Adminer. I like this one. Adminer is a single PHP file that's the simplest database management tool ever. How do you use it? Well, you add it to your compose file, images Adminer, restart always, expose port 8080. Now it says, hey, you can specify external server, you can specify other settings. We're going to keep it super simple. What we're going to do is we're going to set up Adminer. Let me switch back by going in, creating a new service. So I'm going to rename this service from DB to database because I like database being my host name instead. I'm also going to switch to the YAML tool so I can format this. Indent using spaces too. A little crazy about my indentations. Switch back to Docker Compose. Oh, for those who've never seen that before, you can actually change which tools being used by Visual Studio Code to do your highlighting, editing, your IntelliSense. So right now it's using Docker Compose, which is okay, but I switched to YAML so I can get a little bit different highlighting to make it easier for me to switch from 3 tabs to 2. I don't like the whole 3-tab spacing. I can't read it at all. All right, so we have our database service. We'll create a new service. I'm going to call this admin. And for my admin service, I'm going to use the image adminer. Did I spell it right? Probably. Restart always. I can set it to depend on, but I don't need to really do that. So going to expose some ports. Enter. It uses port 8080. So I'm going to say 8080, and I'm going to map this to port 4125. And then I can set environment variables, but I don't think I need any for adminer. I think I'm good to go. So if I hit save, we'll see to stop Docker Compose. Clear this, Docker Compose up. Uh-oh, it says DB1, no such service. Hang tight. Let's see if I have a typo here. Service called database. Service called admin. Make sure I didn't miss it, didn't have any typos. And just in case, I'm going to just remove any existing containers to keep things simple. All right, I think I have it corrected. Don't think I have any typos, so Docker Compose up. There we go. Creating 2 containers, Compose Database 1 and Compose Admin 1. It's doing the same thing with MySQL, so it's gonna get everything going with MySQL. Notice for the admin side, it's just one thing. Hey, development server started, much simpler. It's running MySQL scripts to insert data. It's gonna shut down the MySQL database and restart it, and it's ready for connections. Awesome, port 3306. So you notice I have 2 containers running. One is for my database, exposed using port 3306, and one is for Compose Admin, exposed using port 4125, mapping to 8080. So if I select that, 4125, let's see, go back in here, go localhost 4125. There's the adminer. My server name is database. My username is Contoso. Password spaces. Database is called Contoso DB. Hit login. There we go. There's our locations table. We see data in our locations table there. And I'm just going through this really fast. There's our, if we go to Contoso DB schema, there's our location rooms table. There's our data in our location rooms table with different pricing data. So really cool. That's how we can actually use two different containers. So we have one container for MySQL database and one container with the adminer tool. We can use that with other tools. Like if you use PHP at myadmin, you can do that too. PHP myadmin. I think the only difference with PHP myadmin assumes the host will be it assumes the host will be DB. And if it's not, you need to change it. So for PHP myadmin, you can say environment, and there's an environment variable called PMA host. And I'll say my host name is database, not DB. And if you're like, how did I find that out? Well, I went to Docker Hub, searched for PHP myadmin, went to the PHP myadmin image, scrolled down. It says, hey, you can specify the MySQL host in a PMA host environment variable. You can also specify PMA port if you use a different port here. All right, instead of 4125, let's do 4250. For our port number, we're going to go to Windows Terminal, close down existing Docker Compose, clear my screen, Docker Compose up. Let that kick off. You'll notice admin started PHP myadmin. So if I go here, there's PHP myadmin at port 4250. Did I get something wrong? Let's see. Let's just double check. And we ran into our demo bug of the day. Just double check my notes, make sure I didn't screw anything up. PHP myadmin runs at port 80, not 8080. Stop my Docker Compose run, Docker Compose up. It's one of the cool things that you can just change this. You see how quickly I can get back and forth to trying things out. So hit refresh. There's PHP myadmin, Contoso, spaces, hit go. Contoso DB, location rooms, and location. So we can definitely use a variety of administrative tools. Okay. So I've shown you enough about Docker Compose. What I'd like to do is take this information we learned about Docker Compose and apply it to a solution. So we have our data.json file here, and I'll show you how I can simulate that data using Docker Compose and MySQL. Let me actually show you a real world usage for this. Is we're going to have origin Docker multi-container branch on my multi-container repo. And in here, you notice I have a Docker Compose YAML file. Now this one's a little bit different, but I just want to call it out. The MySQL is the same, init Docker entry point. This sees the data. But notice instead of saying image under my admin, here I can change that from admin to website or just web. And instead of saying image, it says build. What does that mean? Well, that says instead of taking an existing Docker container image, just build this Docker file and run that. We'll take port 80 and expose it at port 4000. I'll just expose it at 4782. Hit save. And then what I will do is I can run Docker Compose in this folder. So just close out. And just so you see everything, no demo tricks or anything. I'm going to delete all my stock containers. Just keep things simple. CD out of my Compose folder. I think this folder is called Fun Deploy, where my application is. Docker Compose up. It's going to do two things. One, it's going to do the same thing with MySQL. And then the other thing it's going to do is going to build my Next.js web application and use that for the web part, web service within this Docker Compose file. So we'll just go back to Windows Terminal. You notice it's running a build. That takes about 30 seconds. And that will allow me to build this application and essentially have a multi-container application running locally. Now, when we're ready to take this application and run it remotely, we can do a couple things. We could take this MySQL database with its changes and commit it as a new image. And I've actually done that in Docker Hub. I have an image called, it's under MSFT US Dev, called Next Site Dynamic DB. We can do the same thing for this web application. We can publish that image, which I've already done using Next Site Dynamic. So I'm gonna let this run locally first. So just so you can see it works. And somebody says, hey, if I want to use Visual Studio to do a lot of this work, can I do this in Visual Studio? Absolutely. There's a lot of Docker tools in Visual Studio. I just feel like the Docker management experience in code is really good and really mature compared to some of the other platforms. So if you want to run it in Visual Studio, you can, but you can definitely like do your Docker management in code on the side while you're writing your code in Visual Studio. Somebody says server equals database. That is absolutely a title. Thank you. Typo. Thank you. All right, so there we go. MySQL is listening. We did our seed data. The application is built and running. Everybody's happy. So if I go to my Docker extension and scroll all the way to the top, we'll see we have Fun Deploy Web and Fun Deploy Database. Fun Deploy Web is exposed to port 4782. There's our Contoso space site, but this time we are actually serving real live MySQL data as opposed to using a built-in data JSON file. So that's pretty cool. And I've already published both halves of this as container images. So I don't even, like in dev, I can use this type of Docker Compose files. So I can always get the latest and always rebuild. But if I'm pushing this to production, I can create a new file. Let's see, Docker, let's call it Docker Compose prod.yaml. And in this production one, I can keep it even simpler. I can say, all right, version 3, my database image is MSFT US Dev, next site dynamic DB, restart if there's a failure. My website image, I don't know why I keep putting an admin here, it's web. My website image is MSFT US Dev, next site dynamic, which is my next site. Restart always, expose port 80 as 80, and put in a connection string pointing to database, not database, Contoso DB, Contoso, and password spaces. Let's try that out. So we're going to go to the portal, and this will be the last thing we do today. We will create a new web app under MSUS Dev. We will call this Sydney Next Dynamic Site Docker Container ECUS. I know this was really demo heavy, but I just wanted to show a lot today in a little amount of time we have each day. Docker Hub for my image source. Gonna go, we're not in the compose folder anymore. We're gonna go to Fun Deploy. There's my prod YAML. Hit review create. Hit create, and it's deploying my very complex application. Now, notice I have a different file for Docker Compose locally in dev than I have in prod, but the idea here is that I can just do different types of scenarios here. So for instance, in dev, I always want to rerun the seed script, and I always want to rebuild the Docker container. But in production, just pull it from our Docker Hub instance, whether it's a private or public one. Somebody says, how do you avoid losing data if your database is in a container and stops? So for dev, the answer for me is I don't care because I want to reseed the data. In prod, the answer is if I need a database for data that's rarely going to change, then I want it to be part of my Docker Compose file. If I want to keep some of the data and have it live beyond this instance, I can mount a volume, and then that volume will show up in and this is me going off of memory, I believe it's in Azure Storage where the volume will show up, and that's how I can have data persist across sessions. But the answer becomes once we start getting out to global scale things, I start recommending using a database service instead of a database part of your multi-container deployment. But you still might use the multi-container deployment because you might have a container for your front end, a container for your middle tier stack, maybe a container for your custom business logic, run asynchronous jobs, a container for any custom cache logic. Like for instance, I might have a different cache instance for each app service instance, and that's fine. I don't really want to distribute that as opposed to a cache service. but I might want to distribute my data in a database service. The answer here is that there's a lot of different ways you can compose and build your application. And you don't have to do it exactly the same way I'm doing it. I'm just doing this as a demo to show you that you can put your database and web in two different containers side by side. But you can also do all sorts of stuff like running a sidecar container to collects metrics and telemetry and sends that to a service. You can run a sidecar container to do your caching. You can run a sidecar container to do auxiliary business logic that you don't want to run in your main container. Lots of different options here. So we're going back in, deployment's complete. And this is going to take a second, but there's our Sydney Next Dynamic site. Go to Deployment Center and go to Logs. We might get lucky. The logs might be ready right away. So this is the last demo day, giving people opportunity to ask as many questions as they need while we're still here. It looks like it's already ready to serve requests. No way, that was fast. But there we go. There's our multi-container web application running in Azure. So that's everything I wanted to show today. I ran definitely a bit over what I originally anticipated, but I'm really glad I got to show you everything that I wanted to show today. Sometimes I get to miss stuff. I'm going to have show notes for this up within the next hour. It was just I changed some of the show notes about 15 minutes before we went live. So that sometimes that's what happens when you really want to show off things. I'm going to try and answer a couple more questions before we wrap up. Let's see. People saying, hey, somebody was saying, yeah, great to see you could do this in different ways. Try to show, let's how to do it in Portal. Let's do it in Visual Studio Code. Let's do it using the terminal. I like to show you all the different ways because in real life, I will use whatever three of the ways is most convenient. If I'm already in a terminal, I'm going to keep using the terminal. If I'm already in code, I'm going to just use the Docker extension. If I'm already in a portal, I'm going to just use the portal. Somebody says, can a multi-container app on Azure be scaled? Absolutely. So it's very common to see multi-container applications where you have stuff like your main web application and maybe only a second, third container running a sidecar service. So this is where you use, there's one that's really popular for Azure that I cannot think of the name of right now. So I'm actually trying to look it up right now while I'm answering some more questions. But there's one that's really popular, and let's see, I know there's a discussion community. All right, I cannot find it right now. But there's a really popular container sidecar that you can use for telemetry collections, for monitoring services, for sending messages in an event aggregation pattern. And it's not uncommon to deploy a multi-container app just so that you can have your web application one container in this sidecar, which is provided by a third party running in another container that does all that telemetry collection, that does that messaging between instances and marshaling of data. So the great thing about having that flexibility is that you can still scale that out because if I have 10 app service instances, I'll just have 10 sidecars. Now, when you start thinking about database, maybe if you're going to scale out, you want to explore using a database service as opposed to a database as a sidecar. But if this is ever only going to be a single instance, the database sidecar is perfectly fine. A lot of people are really excited about the tools we're using. If you follow us on youtube.com/Microsoft Dev Radio, we use these toolings for almost all of our demos. So I have a ton of stuff on there, playlists where you see a lot of these tools. And then we're definitely going to make sure I get some videos up there. And Matt's picking on me about this. I've been meaning to do it for a couple months now. Get some videos up there about my dev workflow, like how I use Windows Terminal, how I use Visual Studio Code, because we use that quite often. And not only workflows, but I use that in my day-to-day development. Somebody says Visual Studio. You can definitely, Docker has been supported in Visual Studio for a couple of versions now. So you definitely do Docker development. This just gives you another option for managing your Docker containers, because I actually like Docker file and Docker Compose file development within Visual Studio because it's a little bit better intelligence, in my opinion, than code. But that code extension where you can manage your Docker containers, nothing beats that. So I actually encourage people to use a variety. So for example, just last week, I was working on a .NET and JavaScript command line tool to deploy a sample database. So I was deploying the JavaScript one was written in Node.js and it was going to be deployed to npm, so you could npm install the global tool, or the .NET version is going to be a .NET tool, so you could .NET tool install that globally. And then the idea here is that you could deploy this database by just running this tool and specifying what data sets you want. And when I was doing that, I did all my development of Visual Studio, but the actual deployment of things, I use Visual Studio Code in a second monitor, and that's where I deployed container images. Somebody's extension I use for SQL. You don't need an extension for SQL if you have. I don't think I have an extension installed for SQL. Let me just look real quick. So I have a init folder. There's my init folder. The SQL syntax highlighting is built in. There we go. Is built in to Visual Studio Code. As a matter of fact, I'm just going to look at my extensions list. I'm pretty sure I do not have a SQL extension installed. Oh, nope, I'm wrong. I have a SQL Beautify. But I had syntax highlighted for SQL already, but Beautify is what allows me to open hit F1 and format document, and it formats everything in a nice way. So there are SQL Beautify and formatting extensions, but the actual syntax highlighting is built in. One last really good question. We'll wrap up today. Somebody says, hey, what's better? Is it better to develop a Docker file that has your build instructions, that's your actual build source of truth? Or is it better to actually log into a container and then build within the context of that container? Or not log into, but have a container already instantiated and then take that container and just build from there. The answer to that is going to surprise you. You can do both, or you can do neither. The cool thing is that you have a lot of flexibility. So for example, you can use Visual Studio Code to reopen your workspace in the context of a container. So if you're doing your dev builds within a container, you absolutely can do that. You can also run Docker within Docker. And we do this quite a bit in some of the official Azure courseware, whereas you're running within a Docker container image. We've installed certain versions of Node, certain versions of .NET, Ruby, and PHP. And then we also have Docker running within there. So you can actually, within this Docker container, build other Docker containers. And so that's not uncommon at all. So wherever you want to use your Docker file to do your build, or you want to actually log into a Docker container image and do your build within that, you can do it. And you can do both together. So you can log into a Docker container image, still have a Docker file, and still do a Docker build. Just to point that out, since that's my last question for today, when you're within Visual Studio Code, I believe it's an extension. Let's search for container. There we go. It's the remote containers extension. So this allows you to actually open up Visual Studio Code within the context of a container. So just to show you what that looks like, I'll open a new folder, create a new folder called test. Here's my test folder. I'm going to hit F1. Where is it? Remote containers. Let's see, reopening container. Just giving the extension a chance to start up. All right, so it says what container I want to open up. I have some built in. I can open up it within the context of another container. So I'll just open it within node 14. And it's my same Visual Studio Code development environment, but notice it's actually starting a dev container. Now, Microsoft has their own versions, MCR, Microsoft.com, VS Code, dev containers, JavaScript, Node, and I believe that's open source. So you can actually go look up and see how they built their Node container. And it comes with some of the most popular tools you're going to do for Node. You can build your own dev containers. So for the official Azure courseware, we have a Docker container image with everything officially installed. And what the students do when they take their first class is they actually go in, and we do this with college classes. They have the dev container file, and it has our Docker file, and it has everything that you need to install to complete our class for the whole week. And then they reopen Visual Studio Code in the context of that dev container. And then that way we don't have to worry about what's installed on their machine or what's not installed on their machine. Everything is pristine and perfect. So this is incredible and wonderful if you're running a big development team. And if you don't know that much about it, I highly recommend going back and look at the Microsoft Build sessions that go too deep. They go pretty deeply into this. So thank you everybody for your time and hanging out for the Q&As at the end. We will see you for our last session where we're going to go into connecting other Azure services to Azure App Service. Thank you again.
Thank you, everybody, and thank you, Sydney.